Alright, so hopefully everybody's had a great spring break. We're going to start off today. We're going to start naming acids. And this is very, very, very similar to how we named things before, so let's do a quick review of naming compounds, and we'll grow it out of that. We saw before we had something like copper to nitrate was the name. And we'll go back and forth and do this both ways. But if they gave me this name, I would just start out with the name of the metal. It's just the metal. The Roman numeral is the charge of that metal. And then nitrate was that polyatomic, and they have a set charge. I've got to make these two charges the same, so I've got to times this one by 2, so boom. That's how we would go from the name to the chemical formula of copper nitrate. If they gave me the chemical formula and I was looking for the name, so let's say I had Rb3n, then I would just write down the name of the metal. So this would be my metal, and I'd say rubidium. Then I would write down the charge of that metal. We know that nitrogen is a -3. It likes to be a -3. We know that rubidium is always going to be a +1. So in this case, because of where rubidium is, it's in that first group. We don't have to write it, but it's never wrong to write it, so we'll put the 1 there. It's going to have a charge of +1. Then we'll go with the non-metal. In this case, it's nitrogen, since it's the only thing we changed the ending to "ide", so it's nitride. Okay, so that's it. That's how you would name. So that's the review part. We're going to take this, and we have a very special case that happens sometimes, going back to that first one where we had copper nitrate. If the metal, okay, this guy right here, happens to, instead of being a metal, it's hydrogen. Okay, so instead of having copper there, we would have hydrogen nitrate. If that is the case, then this is an acid. Okay, and so we're gonna change the naming just a bit to denote that it is an acid. All that we're going to do is we're going to say, okay, we know that that hydrogen is an acid, so we're not going to name it. So we look at what it's paired with. So we have NO3 is what it's paired with. That's nitrate. Okay. If it ends in ATE, we just drop that and change it to ic and add acid on the end. So that becomes, so HNO3 becomes nitric acid. Okay, so if it's any of my polyatomics that end in ATE, so HCO3, H2CO3, okay, we know that this is carbonate. So we've got this 8 ending. It's one of our polyatomics. We cross that out. We put IC acid, and it becomes carbonic acid. Okay. If, on the other hand, it's something like HCl, well, my H is still my metal. Remember, the metal always comes first, and so it's that special case where we know that this is an acid. If it ends, so in this case it would have been a chloride, right? Because it's just chlorine, and so we changed the ending to IDE. Alright, if it ends in ide, we're going to do the same thing that we did before. We're going to change that to an ic, but on the front we're going to put hydro. Okay, so HCl becomes hydrochloric acid. Okay. So play with that a little bit. If you have any questions, come in and talk to me. Basically, if it's 8, we're dropping the 8, changing it to ic acid. If it's ide, we're dropping that. We're putting hydro on front, then the word ic acid. All right, we'll talk to you next time.